An important aspect of coordination chemistry is the nomenclature of coordination compounds. The names and formulae of coordination compounds are written by employing the rules published by the International Union of Pure and Applied Chemistry, or IUPAC in short. Let's look at the rules framed by IUPAC for writing the formula of a complex. The first rule is the formula of the cation, whether it is simple or complex, is written first, followed by that of the anion. For example, in the complex shown here, the cation sodium is written first, followed by the anionic coordination entity. Similarly, in the complex containing a complex cation and a complex anion shown here, the complex cation AgNH32 is written first, followed by the complex anion AgCN2. The second rule is that within the coordination sphere, the symbol of the central atom is written first, followed by the symbols or formulas for the ligands in alphabetical order, irrespective of the charge on them. For example, in the complex shown here, the metal atom cobalt is written first, followed by the ligands ammonia and chloride. Polydentate ligands are also listed alphabetically. While listing in alphabetical order, the first letter of the abbreviation of the ligands is used to determine their position. For example, if a complex contains chloride and ethane 1,2-diamine, which is abbreviated as EN, then in alphabetical order, chloride is written first, followed by ethane 1,2-diamine. Another rule is that the formula for the entire coordination sphere is enclosed in square brackets. For example, in the complex shown here, the coordination sphere containing the metal atom copper with 4 bromine atoms are enclosed in square brackets. The cation potassium is written outside the coordination sphere. The formulae for polyatomic ligands and the abbreviations used for the ligands are enclosed in brackets. For example, EN, EDTA, PY, etc. are enclosed in brackets. For example, in the complex of cobalt shown here, the coordination entity contains the polyatomic ammonia ligand and the abbreviated ethane 1,2-diamine ligand enclosed in brackets. One more rule is within a coordination sphere, the metal atom as well as the ligands are listed without any space between them. For example, in the complex of cobalt shown here, the ligands ammonia, water and chloride are listed without any space between them. Yet another rule is that when the formula for a cationic or anionic coordination sphere is to be written without that of the counter-ion, then the charge with the number before the sign is written as a right superscript outside square brackets. For example, the complex ions of cobalt and chromium with the charge on the respective ions are shown here. Now let's see the IUPAC recommendations for writing the names of complexes. The first rule is, for coordination compounds that are ionic, that is, the coordination sphere serves either as the cation or the anion of the ionic substance, the cation is named first and separated by a space from the anion. For example, in the complex K4FeCN6, where the coordination sphere is an anion, the cation, potassium, is named first and separated by a space from the name of the anion. On the other hand, in a complex such as CONH3,6Cl3, where the coordination sphere is a cation, the cationic coordination sphere is named first, followed by the name of the counter anion, chloride. The second rule is, while naming the coordination sphere, ligands are named first, followed by the name of the central metal atom or ion with its oxidation state in Roman numerals in parentheses. Remember that irrespective of the charge on the ligands, they are named in alphabetical order. For example, in the complex PT-NH3-2Cl4, the ammonia ligands are named before the chloride ligands according to the alphabetical order, followed by the name of the metal ion with its oxidation number enclosed in brackets. IUPAC has also proposed certain rules for naming ligands. Anionic ligands are given names that end in the letter O. When the name of the free uncoordinated anion ends in ate, the name of the ligand is changed to end in ato, ATO. For example, the anion acetate is named acetato, sulfate as sulfato, thiocyanate as thiocyanato, and carbonate as carbonato. When the name of the free uncoordinated anion ends in ide, IDE, the ligand name is changed to end in ido, IDO. For example, the anion fluoride is named fluorido, chloride as chlorido, bromide as bromido, and iodide as iodido. Similarly, nitride is named nitrido, amide as amido, and azide as azido. Neutral ligands are given the same name as the uncoordinated molecule. For example, pyridine, dinitrogen, dioxygen, and triphenylphosphine. However, some neutral ligands are given special names. They are aqua for water, amine for ammonia, nitrosyl for nitric oxide, and carbonyl for carbon monoxide. Positive ligands, such as nitronium, hydrozinium, and nitrosodium, are named as such without any change. Another rule says, if several ligands of the same type are attached to the central metal atom, then their number is indicated by the prefixes di, tri, tetra, penta, etc. For example, in the complex CONH3, 3H2O Cl2, the 3-amine and 2-chlorido ligands are indicated by the prefixes tri and di, respectively. However, if the name of the ligand in question already includes a numerical prefix, then the prefixes like bis, tris, tetrakis and pentakis are used. For example, the complex RuCl3 PPH33 is named as tris-triphenylphosphine trichlorido ruthenium 3. Here's another rule. When the coordination entity is either neutral or cationic, the usual name of the metal is used. For example, the neutral complex shown here is named triamine trichlorido cobalt 3. Similarly, the cationic complex CrH2O 4Cl2Cl is named tetra aqua dichloridochromium 3 chloride. Note that, in either case, the usual name of the metal is retained. However, when the coordination entity is an anion, the name of the metal ends with the suffix -ate. For example, the anionic complex NaPtNH3 3Cl3 is named as sodium triamine trichlorido platinate 2. For some metals such as iron, copper, silver and gold, their Latin names ferrate, cuprate, argentate and aurate are used. For example, the complex K2CuCl4 is named potassium tetrachlorido cuprate 2. Similarly, the complex NaAgCN2 is named sodium dicyanoargentate 1. Now is the time for practice. Apply IUPAC rules for writing the formulae in the first question and for writing the IUPAC names for the given complexes in the second question. Question 1. Write the formulae for these coordination compounds. Tetraamine aqua chloridocobalt 3 chloride. Dichlorido bis ethane 1,2-diamine cobalt 3. Tetracarbonyl nickel 0. Question 2. Write the IUPAC names of these coordination compounds. Let's write the formula for the first complex. The coordination sphere is the cationic part in this complex. For writing the coordination entity, the symbol of the metal is written first, followed by the symbol or formula for the ligands. Hence, the coordination sphere is written as CO followed by NH3 and H2O ligands in brackets, followed by Cl. The next task is to balance the charge on the cation with the charge on the anion. Since amine and aqua ligands are neutral, and there is only one chloride ligand inside the coordination sphere, the charge on the complex ion is +2. Hence, two anions can neutralize the charge on the cation. Thus, the formula for the given compound is CONH3 4H2O ClCl2. Similarly, the formulae for the other two complexes are written as shown here. Coming to the second question. The first complex is a cationic complex and has two chloride ligands and two ethane 1,2-diamine ligands. The oxidation number of cobalt, as calculated here, is +3. Following the alphabetical order in naming the complex, chlorido-ligands are named first, followed by ethane 1,2-diamine. The number of chloride and ethane 1,2-diamine ligands is indicated by the prefixes di and bis respectively. Thus, the IUPAC name of the given complex is written as dichlorido bis ethane 1,2-diamine cobalt 3. Similarly, the IUPAC names of the other complexes are written as shown here.